Welcome to the Agrawal classes. I am Ajit Agrawal. Today we will study the impact of jets. In this particular case, we are having, first we will consider the force exerted by the jet on the stationary plate. Here we will be having the three cases. First case will be when the plate is held normal to the jet, when the plate is held inclined to the jet, and third, when the plate is curved. So first we will consider when the plate is held normal to the jet. What is jet? Basically, jet is a fluid stream issued from the nozzle with a high velocity, that is having a high kinetic energy. So here say we are having a plate. Here we are having a plate and it is held, it is fixed, it is not moving, it is stationary, and a jet is striking perpendicular to the plate. That is, this angle is 90 degree. Say the area of the nozzle is A, the diameter is D at the inlet, at the exit of the nozzle, and say the velocity of the jet is V meter per second. The fluid is having a density of rho, and as we had already discussed, the area of the jet is A or the diameter of the nozzle is D. So we'll try to find out what is the force exerted by the jet. So first we'll consider that as the fluid is moving with a velocity of V, so in 1 second it will move a distance of V meter, and the area is A. So this is the volume of the jet per second issued or is striking the jet, multiplied by the density. This will give me the mass flow rate per second issued from the nozzle. When it is striking the jet, it is having an initial velocity of V, and the exit velocity is somewhere here. In all the directions it will be scattering, and in the x direction, if we consider, the velocity after striking will be 0. So we will try to calculate the change in momentum, that is the impulse law will apply. The force exerted in the x direction is equals to mass into initial velocity minus mass into final velocity. So we will be having a force of rho V square A. This is the force exerted by the jet on the plate, which is held perpendicular to the fluid. This is the first case. So we will be having a formula of Fx equals to rho V square A. Now we will consider the case 2, when the plate is held inclined to the jet. Here we are having a nozzle, this is the nozzle, and a high velocity jet with a velocity of V is coming out from the nozzle and is striking this fixed plate with an angle of theta. So when it is striking the liquid, the jet is bifurcating or is dividing in two parts, as Q1 is going, say, in this direction parallel to the plate, and Q2 is this fluid that is going downward along the plate. So we'll try to find out the force exerted by the jet. In this particular case, the mass of the fluid is striking the plate will be again the same, as jet is having a velocity of v and the area a. So this is the volume which is striking the plate per second multiplied by the density. So this is the mass flow rate striking the plate per second. Now to find out the force, we'll first try to find out the normal force which is on the plate striking, force exerted by this jet normal to the plate. So in this case, this V will be, say in this direction, it will be V sine theta. So the initial velocity will be V sine theta and final velocity perpendicular to the plate will be 0. So into mass, that is V A rho. This will be the change in momentum and that will be equal to the force in the normal direction, this normal to the plate. So this will come out to be rho V square A sine theta in the normal direction. And if you wish to find out the force in the x direction, say this one is theta, so this is 90 minus theta, so Fn sine theta. So Fx in the x direction, it will be rho V square A sine theta into sine theta, that is rho V square A sine square theta. And in the perpendicular to the plate, the force, not perpendicular to the jet, the force Fy will be equals to rho force Fn rho V square A sine theta into cos theta. So this will be the force exerted in the perpendicular direction from the jet. So we will write here the force Fn or say Fx only. Fx equals to rho V square A sine square theta and Fy equals to rho V square A sine theta cos theta. This is the force exerted. As the fluid is striking on the inclined plane, the jet is divided in two parts, Q1 and Q2, and if we wish to find out the value of Q1 and Q2, then we can take the force in the parallel to the plate. Parallel to the plate, the force will be equals to 0, and so we will apply this momentum equation for this particular plate in the parallel direction. So here it will be rho Q1V minus rho Q2V. This is the change in momentum. If Q is the volume, rho is the density, then this becomes the mass multiplied by velocity. So this is the force in this upward direction minus rho QV cos theta. Rho QV cos theta, this one is giving me a component in this upward direction, and this change in momentum will be equals to 0. So from this equation, I can calculate Q1 minus Q2 minus Q cos theta equals to 0. That's equation 1 I get, and from the continuity equation, Q1 plus Q2 is equals to Q. So if we solve this particular one, we will get Q1 equals to Q by 2 1 plus cos theta, and Q2 equals to Q by 2 1 minus cos theta. So from this, if you want to find out the ratio of the discharge, say Q1 by Q2, then it will become 1 plus cos theta upon 1 minus cos theta. So this will be another equation, will be useful if we wish to find out the quantity of fluid moving in the upward direction along the plate or in the downward direction along the plate. So this way we can calculate the force exerted on the plate, which is held inclined to the jet. In the x direction, this will be the force. In the y direction, this will be the force. And if we wish to find out the normal direction, then we had already calculated it as rho v square a sin theta. Let us consider the third case, when the plate is curved and we are going to find out the force exerted by the jet on the stationary curved plate. In this case, we are having two cases. First, we will consider jet strikes the curved plate at center. Here you can see this H portion is a curved plate and it is stationary, and the jet is striking at the center of the plate. If you make the tangent at the exit tip, then here the angle is equals to 2 theta and a half angle is theta. The jet is coming out through the nozzle with a velocity of v. The density is rho. The area of the jet is A, or the diameter of the nozzle is D. So in the x direction, say this is the x direction and this is the y direction. So in x direction, the initial velocity is v and the exit velocity is v cos theta, because the jet is moving in this direction and is dividing in two parts because the jet is striking at the center. So the exit velocity in the x direction is v cos theta, but it is in the opposite of the v. So it is minus v cos theta. So we can find out the force Fx is equals to change in momentum. Mass flow rate is rho a v. A into v is the volume per second multiplied by density. Mass into change in velocity. Initial velocity is v and my final velocity is minus v cos theta. So Fx becomes rho a v square 1 plus cos theta. Okay, before writing we can also write like that. Fx is equals to rho a v vx1 minus vx2, that is velocity in x direction minus velocity in x direction at the leaving point. So vx1 we are writing as v and vx2 is equals to minus v cos theta. So we get this as the force Fx in the x direction. Fy equal to mass flow rate multiplied by Vy1 minus Vy2, that is initial velocity in the y direction minus final velocity in the y direction. So initial velocity is 0 and the final velocity is v sin theta. So we will write here. So this becomes minus rho a v square sin theta, that is in this particular portion, and in this particular portion this will be equals to rho a v square sin theta, and the total force if we will consider, then it will be 0 in the y direction when the jet is striking the curved plate at the center. That is the first case. So here we can write fx equals to rho a v square 1 plus cos theta. Okay, the general formula we are going to use this one. Fx equals to rho av vx1 minus vx2, and for fy it is rho av vy1 minus vy2. In this case, one more point has to be remembered, that the jet is deflected by 180 minus theta degree, because the jet is moving in this direction initially and then it starts moving in this direction. So this is the angle of deflection of the jet. So it is 180 minus theta, and here the 2 theta is the total included angle of the curved blade. Now let us consider the second case, when the jet strikes the curved blade at one end tangentially. That is, in this case, we are having a curved plate and the jet is striking the curved plate tangentially, okay, with a velocity v, and as we are assuming the plate is frictionless, so the exit velocity is also equals to v. Say the inlet angle, let the jet is making an angle of theta degree with the x direction at the inlet point and theta degree at the exit point, as shown in this figure. Okay, now we'll find out the velocity in x direction, initial velocity and final velocity, and we know the mass flow rate. So the change in momentum is equals to the force. So Fx, as we are writing, mass flow rate rho into A into V multiplied by Vx1 minus Vx2. The initial velocity in x direction and the final velocity in x direction. So here it is rho a v, Vx1, that is inlet velocity, is v cos theta minus v cos theta. Okay, because this is in the reverse direction. So this becomes rho a v cos theta into 2. So this is the force exerted in the x direction. Similarly, the force exerted in the y direction is given as mass flow rate into change in velocity in the y direction. If we are considering this y direction upward is positive, the initial velocity is v sin theta minus final velocity is also v sin theta, or before that we can write Fy equals to rho a v Vy1 minus Vy2. So initial velocity in the y direction is v sin theta, and final velocity is also v sin theta. So in this particular case, the Fy will become 0. Fy will become 0. So this way we can find out the force exerted in the x direction as well as in the y direction. This is the one case where we had considered the blade is symmetrical. हमने अभी तक देखा कि blade symmetrical है, but say the inlet angle of the blade is theta and the exit angle of the blade is phi. ठीक है? Then what will happen? In that case, the Fx will be equals to rho a v. Vx1 will be, as it is theta, so it is v cos theta minus here it is phi, so it is v cos phi now minus v cos phi. So this will become rho A V square cos theta plus cos phi, where theta and phi are the inlet and outlet angle of the blade, and Fy will be equals to rho AV Vy1 minus rho Vy2. So it is rho AV Vy1 will be equals to V sin theta minus here V sin phi. So this will be the formula as it is, rho A V square sin theta minus sin phi. So this will be the formula to find out the force exerted when the blade is unsymmetrical. This is all about the impact of jet.